And yes, we are live. Let's mark the take-home quiz. Otherwise, today is going to be mostly a catch-up period. Tomorrow, we're going to start looking at what happens when there's more than one mass attached by strings. Based on prior experience, I'll get halfway through the lesson. Your homework tomorrow is going to be another take-home quiz. This one's going to be friction and friction and friction and more friction and friction. Okay? Who's my favorite student? Good old Anne. What is the definition of a force? What is the unit of force? I'll do the second part first. What are the units for force? You could say newtons. You could also technically say kilogram meter per second squared because F equals what? F equals what? Everybody. So, oh, it wasn't everybody. Somebody had their mouth full. F equals what? Everybody. Still missing everybody. F equals what? Everybody. We're still going to do F equals what? Everybody until I get David involved as well. F equals what? Everybody. Okay. That means it's kilogram meters per second squared. And really it's F net equals MA. What'd you say for the definition of a force? What'd you write? Yeah. I agree. I'll give you that. I would say what you've given me is the definition of an unbalanced force. Because if forces are balanced, does the object change velocity? But they're still forces. I'll give you that, but I'm going to be nitpicky. Anybody else? Jackson, would you write? Yeah, that's I think push or pull. I'd live with that. Which isn't a good physics definition, but it's one we can remember and the common ordinary non-physics nerd would understand. Okay. Okay. Here we go. Cooper, can you read to me the first three words of number two? What force? What force? I can, as soon as I see that word there, I can go straight to F equals MA. You know what? They gave me M. They gave me A. How many marks was this worth, by the way, Cooper? That usually means plug and chug. In fact, I can do this in my head. 2,400 newtons, yes? That one I'll be fussy, all or nothing. Number three is worth 3 marks. Probably means I'm going to have to find something in order to find something. Now, what do they want me to find? They want me to find, Cody, the what force? The what force? Okay, I said, well, F equals ma, and then I said, oh, this is easy. M is 65, and then I came to a stop. I said, you know what? Even though this says find the net force, I'm going to spend most of my time finding the acceleration. So I said A equals question mark. Ooh, what does at rest tell me, Cody? I already started to smile and say, I think I know where I'm going to find acceleration. What's that 770? What's that 1.5? I said, you know what? There is an equation that has an A, a VF, a VI, and a D in it. It's the squared one. VF squared equals, it's, if I get the A by itself, VF squared minus VI squared all over 2D. It's going to be 770, don't forget the squared, minus 0 squared all over 2 times 1.5. Bracket 770 squared. Does minus 0 squared change anything? I'm not going to bother typing it then. Divided by 2 times 1.5. I got a really big acceleration. At first, that made me nervous, and then I went, wait a minute, this is an artillery cannon. I think it's going to accelerate pretty fast, so I relaxed. I'm going to write 198, but I'm going to use my answer button. So I wrote 198,000 meters per second squared, and then I walked that over to here. In fact, I even just wrote ANS for answer button. Did you all get a big number? 12846 I'm going to write this in scientific notation. 1.28 times 10 to the 1, 2, 3, 4, 5, 6, 7. By the way, forces come in. When this artillery shell hits an object, it will apply that force to the object as well. That's why artillery shells do so much damage. Okay. If you got that 3 out of 3, otherwise I would probably give you half mark if I saw that, 1 mark for the answer. I would give you a half mark if I saw that. 1 mark for finding the acceleration. So if you got the acceleration wrong, you can still get 1.5 out of 3. Jordan, can you read to me the first 3 words of number 4? A what force? A what force? You know what? I can go straight to F equals ma. Only this time, what do they want me to find, Jordan? That magnitude just means size or answer. So what? It's going to be Cooper's theorem, and it's 1 mark. You know what? I guess I'm just going to go like this. In fact, I can do this one in my head as well. I think it's 10, yes? So no free body diagrams yet. Number 5A, they said find the average acceleration. You know what? Although I thought about using Cooper's theorem, I said I see from rest, I see a time. I think I'm going to go VI equals 0, VF equals 3.2 times 10 to the 4th. T equals 32. I said I'm going to use VF equals VI plus AT, getting the A by itself. It's going to be 3.2 times 10 to the 4th minus 0 divided by 32. 1,000? Somebody, I can't remember who was saying, that's a pretty high acceleration. This would definitely be an unmanned probe. This would not be a manned spacecraft. That would not be good. Ooh, okay. Hannah, what does part B want me to find? The average what? What force? I can go straight to F equals ma. 4.5 times 10 to the 4th times 1,000. I wrote this in scientific notation as 4.5 times 10 to the 7th newtons. You'll have a 4, you'll have a 5, and then I think 5 zeros after that. A what force? A net force. Okay. Ooh, how far? They want me to find D. Well, I see from rest, VI is 0. I see VF is 12. What else might I need if I wanted to find a displacement? You know what? It would help, or time, but I'm thinking I'm probably going to find acceleration. So now I walked over to here and I used Cooper's theorem. I said, I know that A equals F over M. They gave me a force, 1.6. They gave me a mass, 6.4. Did you get an acceleration of 0.25 meters per second squared? Is that right? And then I just walked it over to here and I said D is going to be VF squared minus VI squared all over 2A. It's going to be 12 squared minus 0 squared all over 2 times 0.25. I can do that in my head. 12 squared is 144. Divided by 2 is going to be 72. Divided by 0.25 is going to be 72 times 4. So it's going to be 284? No. Yeah? No. 88. 2 times 4 is 8. 288 meters. If you got that, 2 out of 2. Otherwise, I would give you a half mark if I saw that. I would give you a half mark if I saw that. I would give you a half mark for finding A. And I would give you a half mark for finding B. How much time? Now I got a lot of options here. You know what? I would probably use T equals VF minus VI over A. You could also use D equals bracket VI plus VF close bracket times T over 2. You could also use D equals VIT plus a half AT squared, but this was the easiest one to get the T by itself. VF was 12 minus 0 all over 0.25. 48 seconds, is that right? Okay. If you used another method but you got it right, 2 out of 2. If you used another method but you got it wrong, show me and I'll tell you how I give out the part marks. But I'm going to guess most of you fell back on that one. Ooh, True or false questions. A book is sitting on a level desk. Which of the following statements are true? Statement A, there are no forces acting on the book because it's not accelerating. True or false? In fact, what are the forces acting on the book? Get the obvious one. Gravity. And but it is not accelerating, so I do agree with that step. The magnitude of the normal force between the book and the desk equals the magnitude of the gravitational force on the book. That's wordy, but true. Yeah, I had to phrase it very carefully. The net force on the book is equal to 0. Is the book accelerating? You know what that means? The net force is equal to? That's true. Ooh, friction is what's holding the book on the desk. If you ask me a friction question, one of my strategies is I replace the desk with a block of ice. If we were on a horizontal block of ice, could the book still sit there and stay at rest? Yeah, you know what? I don't think friction is holding it on the desk. So FTT, FTTF, half mark for each one. I like number 8. I like number 8. I like number 8. It's already on the quiz. What do you? Oh, I get it. First thing that I did is I said, "Nice try, Mr. Dueck." Is that a mass? No, and you'll notice what word did I use in front of it? Weighing. This is a weight. So one of the very first things that I did was I said the mass is going to be 588 divided by 9.8. I just did that off in the margin somewhere. 588 divided by 9.8. And this person has a mass of 60 kilograms. At least once on your test, I will give you a weight, not a mass. In fact, I think I did it twice. Pay attention. By the way, if you're telling me this person has a mass of 588 kilograms, they're not fitting in the elevator. Just sorry, that's over 1,000 pounds. So it wants the scale reading. No, it doesn't. What, Mr. Dueck, I beg to differ. It says find the scale reading. I beg to differ. When it says find the scale reading, what force are we really talking about? Yeah, I'm going to find the normal force. I'm going to do a free body diagram. So in part A, we would have gravity down. Which way are we accelerating in part A? Which way must there be a bigger unbalanced force in part A? You know what? The normal force must be winning. Now I've got my equation. Normal force minus mg equals ma. They want me to find the normal force. I'm going to get the Fn by itself. I'll move the mg over. This is not swappy dance because there's not a negative in front of the Fn. I'm going to get normal force equals ma plus mg. It's going to be 60 times 1.2 plus. You could write 60 times 9.8, but wait a minute, isn't that 588? I was naturally lazy and just put that there. 660? B, the elevator accelerates downwards. Okay. Free body diagram. We have gravity. I guess if we're accelerating downwards, the normal force must be smaller. Ashton, who's winning then? Good. It's going to be mg. Oh, by the way, on this previous one, if you got the right answer, 2 out of 2. Otherwise, I would give you a half mark if I saw that, half mark for that, half mark for the numbers, half mark for the answers. And that's how we'll mark all of these going forward. So, Ashton, I totally agree. Gravity, who's losing? Normal force, that equals ma. I want to get the Fn by itself. What's right in front of the normal force that I don't like? A negative. Now I'll do that little swappy dance trick. I'll plus the normal force there. I'll minus the Ma there. I'll get Mg minus Ma. That equals the normal force. Mg was 588 minus 60 times 2.25. This person will feel a little bit lighter. By the way, elevators that you've been on, not the amusement park ride like the elevator, but standard elevators, they accelerate maybe 0.5. I'm having to make up bigger accelerations, so there's a bigger difference. But that would terrify people if you actually had accelerations like this, especially the downwards one. Oh, what did I do wrong? I don't know why I multiplied the 588 by 60. That's already multiplied by 60. 453? Again, 0 0.5, 0 0.5, 0 0.5, 0 0.5. Elevator moves up at a constant velocity. Okay. Gravity down. Now, you might be tempted to say, because we're moving up, that the normal force is winning. If you did that, you would go normal force minus mg equals ma, as long as you're not sloppy with your units, because now, if you got the normal force by itself, you would get normal force equals ma plus mg. This is not an acceleration. In fact, constant velocity, what is the acceleration as a number exactly? And so you would get 60 times 0 plus 588, and you'll get 588 newtons. Now, I would hope you didn't do it that way. Nathan, my hope would be you said, because it's a constant velocity, I know forces must be, I'm looking for that starts letter B. I would hope you would just say, I think I can just go straight to that. But that previous that I just wrote, that's a proof that that does work. It is 0, so does work. What if the elevator is accelerating downwards at 9.8 in free fall? If I stood on a scale when I jumped out of an airplane, imagine I jumped out of an airplane, what would the scale read as a number exactly? And that's why the astronauts appear to be floating, sorry, not appear, are floating on the International Space Station, not because there's no gravity. There's plenty of gravity up there. G up there is about 8.8. We calculate it in physics 12. It's because there's no normal force, because they're in free fall. Which again leads to the question, if they're in free fall, why doesn't the space station crash into the Earth? And the answer is because of the physics of orbits. We'll talk about that in physics 12. I'm going to hit pause.